Hi, I'm Peter and this is David. Today we will learn about the 4 types of fluids. A fluid is a material without a fixed shape that flows or deforms easily. Viscosity is the measure of how easily a fluid deforms. A fluid with a high viscosity resists deformation more than a fluid with a low viscosity. For instance, air has a lower viscosity than water.
A fluid deforms under forces, like gravity. Shear stress is a force parallel to the surface of a fluid. When it is applied, the force causes the fluid to move. The farther away a layer of the fluid is from the force, the less it moves during a period of time. The amount the fluid moves is called shear strain. Velocity is dependent on the movement of the fluid, so the velocity is also smaller in layers farther from the force. The variation in velocity over the depth of the fluid is the velocity gradient, and is also called the rate of shear strain. The 4 types of fluids are differentiated by their relationship between shear stress, the rate of shear strain, and their viscosity.
Newtonian fluids, like water, have a constant viscosity under varying rates of shear strain. The resistance to flow remains the same regardless of the magnitude or speed of the force. The viscosity of shear thinning fluids, like ketchup, decreases as the rate of shear strain increases. The faster the ketchup is spread, the less it resists flowing. The viscosity of shear thickening fluids increases as the velocity gradient increases. Oobleck, a mixture of cornstarch and water, is shear thickening. The faster the knife moves, the more it resists flowing, going so far as to appear to tear. Both shear thinning and shear thickening fluids deform under insignificant force. When subjected to gravity, both ketchup and oobleck flow easily. Toothpaste, however, does not flow under the force of gravity, but behaves as a solid. This is because toothpaste is a Bingham plastic. Bingham plastics behave as solids until a certain amount of force, called the yield stress, is met. After the yield stress is met, toothpaste's resistance to flow is constant, like water. Changing the velocity does not change toothpaste's viscosity. The behavior of the types of fluids is showcased by this graph and equation. Shear stress is the product of viscosity and the rate of shear strain. In the graph, shear stress is on the y-axis, the rate of shear strain is on the x-axis, and viscosity is the slope of the line. Newtonian fluids and Bingham plastics have constant resistance, so they have constant slopes. Shear thinning and thickening fluids have non-constant viscosities, so their lines are curved. Bingham plastic does not flow until its yield stress is met, so its y-intercept is non-zero.